So hello and good morning to everyone. So our today's lead code question is 48, which is rotate image. So basically in this question we are given an cross and 2D matrix which represents an image, and what we have to do is we have to rotate the image by 90 degree in clockwise direction, right? So also it is given that we have to rotate the image in place. In place means we can't use any extra space, right? Means we have to modify the input 2D matrix directly, right? We can't allocate another 2D matrix to do the rotation, right? So let's see the examples to get the question more clearly. So if you see, we are given the initial 2D matrix as 1 2 3 4 5 6 7 8 9. So what we have to do is we have to rotate this as by 90 degree in the clockwise direction. So if we shift it, this 3 will come here, this 2 will come here, this 1 will come here, right? Then this 6 will go here, 9 will go here, right? So this way after 90 degree rotation we get this grid, right? So this is what we have to achieve, right? So similarly in this example also we just have to rotate this image by 90 degree, and we have to return the final output in the as a grid. So let's see the constraints. So basically n, which is the matrix length, or that is the number of rows or number of columns. So number of rows and number of columns can be up to 20, and each element in the matrix can be from -1000 to 1000, right? So let's move to the approach part. So basically if we take a coordinate I comma j, so after 90 degree clockwise rotation, after 90 degree clockwise rotation, where will this coordinate I comma j will go, right? So if you see, if we let's try to see it with the help of an example. So we are given the original indexes. So 0 comma 0 will go to 0 comma 2, 0 comma 1 will go to 1 comma 2, 0 comma 2 will go to 2 comma 2, right? Then 1 comma 0, 1 comma 0 will go to 0 comma 1. So if you notice, if you notice from these example, the index I comma j, index I comma j will go to j comma n minus 1 minus I. So this is the old index, this is the old index, and this is the index after 90 degree rotation. After 90 degree rotation, this will be our new index, right? So what we have to achieve now is we have to achieve, for every index I comma j, we want to achieve the new index, that is j comma n minus 1 minus I. But the thing is that if we directly implement this thing, if we directly implement this thing, we need a new matrix, right? And which is not allowed in the question, because in the question it is mentioned that we have to do it in place, that is without any extra space. So we directly cannot convert every index I comma j to the new index, right? So what we do is we split it, right? We split I comma j. This is what we want to achieve, j comma n minus 1 minus I, right? So what we do is we convert I comma j to first j comma I. Basically this is transposing of the matrix, and then j comma I we convert j comma I to j comma n minus 1 minus I. Basically this is reversing the row. So first we take the transpose of the matrix, first we take the transpose of the matrix, and then we reverse the row, right? So we do two steps, transposing and reversing the rows. So transposing converts I comma j to j comma I, and then reversing the row will convert j comma I to j comma n minus 1 minus I. So if we combine both the steps, then I comma j will be converted to j comma n minus 1 minus I, and that is what we want to achieve, that is what we want to achieve, right? So taking transpose and then reversing the rows will give us a 90 degree rotated matrix, and that's what we want to achieve, right? So let's see let's try to understand with the help of an example. So we have taken the same example, right? That is 1 2 3 4 5 6 7 8 9. So first, if we see the if we take the transpose of this matrix, so every row will become column, every row will become column after transpose. So see, 1 2 3 4 5 6 7 8 9. So this is a transpose matrix. Then if we reverse every row, if we reverse every row, then it will become 7 4 1, it will become 8 5 2, and this will become 9 6 3. And that is what, that is the answer, right? So first step is transpose and second step is reverse every row. So now how we'll be taking the transpose? So for taking the transpose, we will take this part, we will take this upper part of the matrix, we will take the upper part of the matrix, and then swap every index. See, I comma j, so this is 0 comma 1, so we swap 0 comma 1 with 1 comma 0, right, in the lower part. So we go to every index, we go to every index I comma j in the upper part, in the upper part, and then swap that index value with j comma I, right? We swap these values I comma j and j comma I. So this will give us the transpose of the matrix. Then after getting the transpose, we just have to reverse every row, and that is what is our answer. So let's move to the code part. So in the code part, we have taken the matrix size, that is n, and then first step is to find the transpose of the matrix. And as we have discussed, for taking the transpose of the matrix, we'll take all the elements from the upper part only. So we are iterating over all the rows, but the, if you see the column number start from I plus 1, right? And j is less than n, j plus plus. So we swap I comma j with j comma I, swap I comma j with j comma I. So after this step, we'll get the transpose of the matrix. So once we get the transpose of the matrix, the next step was to reverse each row. So we iterate over, we take each row, and then we use the reverse function and reverse the row, right? And we do not have to return anything here because our function type is void, right? So this way we will get a 90 degree rotated, clockwise rotated matrix using two steps, that is transpose plus reverse. So I hope I'm able to explain you the solution properly. So if you like the solution, please make sure to like, share and subscribe the channel. Thank you.